For decades, Intel was the undisputed king of the semiconductor industry. Its processors powered the vast majority of personal computers around the world. From the rise of the personal computer in the 1980s to the internet boom of the 1990s and early 2000s, Intel sat at the center of modern computing. The company's famous slogan, "Intel Inside," became one of the most recognizable technology brands in the world. At its peak, Intel was not just a chip company. It was the company that defined the pace of computing innovation. But today, the semiconductor industry looks very different. Companies like NVIDIA, AMD, and Apple are producing processors that rival or exceed Intel's performance. Artificial intelligence systems rely heavily on GPUs rather than traditional CPUs. And advanced chip manufacturing has increasingly shifted to companies like TSMC. In many ways, Intel has lost the technological leadership it once held. So how did one of the most powerful companies in the technology world fall behind? To understand this story, we need to look back at the history of Intel's dominance. Intel was founded in 1968 by Robert Noyce and Gordon Moore. Gordon Moore is famous for proposing Moore's law, the observation that the number of transistors on a microchip tends to double approximately every 2 years. This principle guided the semiconductor industry for decades. Intel became one of the companies most closely associated with the relentless progress of Moore's law. Throughout the 1980s and 1990s, Intel built a powerful advantage in both chip design and manufacturing. Unlike many companies today, Intel designed and manufactured its own processors. This vertical integration gave the company enormous control over its technology. Intel could optimize chip design and production simultaneously. This allowed the company to push transistor scaling forward faster than competitors. For many years, Intel maintained a clear technological lead. But maintaining leadership in semiconductor manufacturing requires constant innovation. Each generation of chips requires new manufacturing techniques, new equipment, and enormous capital investment. Over time, the complexity of chip manufacturing increased dramatically. Transistor sizes shrank from hundreds of nanometers to just a few nanometers. Producing chips at this scale requires extraordinary precision. Even tiny manufacturing errors can render chips unusable. For many years, Intel successfully managed this challenge. But around the mid-2010s, the company began experiencing serious delays in its manufacturing roadmap. Intel struggled to transition from its 1.4 nanometer process to its 1.0 nanometer technology. These delays lasted years. Meanwhile, competitors were advancing rapidly. One of the most important changes in the semiconductor industry was the rise of the foundry model. Instead of building their own factories, many companies began outsourcing chip manufacturing to specialized foundries. The most successful of these companies was TSMC. TSMC focused entirely on manufacturing technology. By specializing in production rather than design, the company rapidly improved its fabrication capabilities. Over time, TSMC became the leading manufacturer of advanced semiconductor chips. Companies like Apple, AMD, and NVIDIA began relying on TSMC to produce their processors. While Intel struggled with manufacturing delays, TSMC successfully introduced new process nodes. This allowed companies using TSMC to launch faster and more efficient chips. AMD, once considered a weaker competitor to Intel, began producing processors that rivaled Intel's performance. At the same time, NVIDIA was developing powerful GPUs that became essential for artificial intelligence workloads. The rise of AI changed the semiconductor landscape dramatically. Training modern AI models requires enormous parallel computation. GPUs are far more efficient than traditional CPUs for these tasks. NVIDIA capitalized on this trend. Its GPUs became the standard hardware for AI training. Meanwhile, companies like Apple began designing their own custom processors. Apple's M-series chips, manufactured by TSMC, demonstrated that vertically integrated design could produce extremely powerful processors. These developments reshaped the competitive landscape. Intel was no longer the uncontested leader. The company faced intense competition across multiple markets. Personal computing, data centers, artificial intelligence, and mobile devices all required new types of processors. Intel began investing heavily to recover its technological leadership. The company announced ambitious plans to rebuild its manufacturing capabilities. New semiconductor factories are being constructed in the United States and Europe. Intel is also expanding into the foundry business, offering manufacturing services to other chip designers. But rebuilding semiconductor leadership is extremely difficult. The industry has become one of the most complex and competitive sectors in the global economy. Companies must invest tens of billions of dollars into research and manufacturing infrastructure. At the same time, technological progress is becoming more challenging. Transistor scaling is approaching physical limits. New innovations in chip architecture, packaging, and materials are required to continue advancing computing performance. Intel still possesses enormous engineering talent and resources. The company remains a major force in the semiconductor industry. But the era when Intel dominated computing without serious competition is over. Today, the semiconductor landscape is shaped by multiple powerful players. NVIDIA leads in artificial intelligence hardware. TSMC leads in manufacturing technology. Apple leads in custom processor design for consumer devices. And Intel is now fighting to reclaim its place in this new competitive environment. The story of Intel's decline is not simply a story of failure. It is also a story about how the semiconductor industry itself has changed. The race for computing power has become global, and the companies that succeed will be the ones that adapt fastest to the new technological reality.